Created this event, and I'm very happy that you guys all joined. And without further ado, let's start. So here with me is Jan Chui, is a serverless hero, no less. So you'll be hearing about serverless security from a serverless hero. I guess we're very fortunate in that. So Jan, why don't you introduce yourself and go ahead with your talk?
Yeah, sure. Thanks, Tao. So I'll probably share my screen.
Yeah.
Okay, screen two. Can you see my screen okay?
Yes.
All right, let me just share the slides in that case. Let me know when you see the slides.
We can see the slides.
Okay, cool. All right. So I guess, first of all, thank you everyone for joining us on this talk on the serverless security and for joining us on the LessCon as well. So I guess one of the first things that you notice when you go into AWS is that you've got this shared responsibility model where AWS tells you what they are responsible for security-wise and what you are responsible for. And one of the things that's different when it comes to doing serverless on AWS is that now AWS is taking over more responsibilities. So the security of the operating system, the networking, the firewall, and all of that becomes a part of their core competency, which is great. It means that usually that means that you can get a better protection from any attacks against the operating system, because application developers like myself just not very good at being very I guess a discipline and constantly keeping the operating system up to date, patching all the AMIs and things like that. It means that we are better protected from attacks such as WannaCry or the likes of Spectre and Meltdown. In fact, when those two vulnerabilities was announced, I remember spending a couple of days just patching all the Docker images we had or the AMIs we had, but then we weren't even thinking about our Lambda functions. And at that point, I saw a tweet from Chris Munns and said that all the infrastructure that are running Lambda and Fargate has been patched against the Meltdown and the Spectre. And that's when it hit me that, oh, we weren't even thinking about Lambda functions. And that's one of the benefits you get by having someone like AWS taking care of the security of your operating system. That said, there are still a lot of things that are left for us to secure and manage, including all of our own dependencies, but also dependencies of our own dependencies as well. So if you look at the OWASP top 10, the current one is still from 2017. I think there's one now being looked at for 2020. And compare that to the OWASP top 10 from 2010 and 2013, which is the top 10 security risk facing web applications. You can see that very little has actually changed in over many years. And when the guy Pajani from Sneak and his guys looked at some of the top vulnerabilities, top data breaches that happened a few years ago, they found that something like a quarter of the top 50 data breaches happened because applications were using components with known vulnerabilities. And that a lot of websites, something like 77% of the top 5,000 Alexa websites were using JavaScripts with known vulnerabilities as well. And it's not hard to actually understand to see why that's the case, because even some of the biggest libraries out there like React and Angular and jQuery, at some point they've had vulnerabilities in a particular version. Of course, those vulnerabilities was patched, but then it's up to you to make sure that you're upgrading your dependencies, to make sure that you're running on latest versions where you have those security patches. And for example, if you are parsing user agents and using the user agent, the library, then at some point it also had a regex denial of service attack vulnerability as well, where someone can execute a really long a string which almost matches your regex, but doesn't quite, which forces you to constantly backtracking, and then it takes you a long time to compute. So if you're using a Lambda function and you're using user agent library to parse the user agent header, then you will be vulnerable to this, this vulnerability as well. And of course, if you're using SQL databases from Lambda function, then you are also vulnerable to any SQL injection attacks as well, as comically illustrated by this SKCD comic. And it turns out even when you're using NoSQL databases such as MongoDB, it's also potentially possible for attackers to execute injection attacks against them as well. For example, MongoDB's query API has a small vulnerability where someone can execute code to extract data that you don't intend to return. I haven't seen anything along this particular attack vector for DynamoDB yet, and I think DynamoDB's APIs does make it a lot harder to do something like this, but potentially you are still vulnerable to other types of attacks, such as cross-site scripting and so on. And I guess if you're using any sort of relational database, you want to make sure that you're using prepare statements, and also you want to sanitize the user inputs. But also, if you are passing the output from one function to something else, potentially where you're handing off events through SNS, EventBridge, or dropping files into S3 and trigger other functions to process things, then you also want to sanitize your output as well. And this is also very relevant to where you're building user-facing APIs, where potentially someone is able to execute some kind of injection attack and run queries and try to return data you don't intend to. And so having some sanitization in place against your own output helps you stop those data from being leaked where you're not intending to return them. So I think I forgot who said this now, but I think this makes a lot of sense, that security is as much about what your functions should do as well as what it shouldn't do. And this is where you want to be careful and filter out data that you shouldn't ever return from your function. And recently I've been working with GraphQL quite a bit with AppSync, and you probably have heard a lot about GraphQL. It's been gaining a lot of popularity over the years. And turns out when I was doing some research, it's also possible to execute injection attacks against GraphQL endpoints, especially when your GraphQL server just translates those queries into, say, standard SQL query, and you're not doing sanitization against the user input, then you can potentially also be vulnerable to injection attacks, even if you're using GraphQL instead of REST. And there's also other vulnerabilities I've come across in this area using JavaScript libraries that uses under the hood uses the JavaScript's eval, which is evil. And of course, if you're using them in your Lambda function, you will also be vulnerable as well. So I guess the moral of the story is that you want to update dependencies regularly to patch any known issues. However, there's often this, I guess, this trade-off there where when you update into new versions of libraries, sometimes you get other bugs instead. And so it's not quite as easy and straightforward as it is to sometimes apply OS level patches. So my name is Yan Cui. I'm, as Tao mentioned, I'm an AWS Serverless hero, and I've been a long-time user of AWS as well. I've been running production workload on AWS for over 10 years now. The last couple of years, I've focused on the serverless space, including migrating a social network to run pretty much entirely on serverless. Nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo is a troubleshooting platform for serverless applications where you have a single place to go to see all of your logs and your traces. You can see them side by side as well. And the other half of my time, I spend working as an independent consultant where I work with customers directly to try to help them go faster by adopting serverless technologies, by providing them with training, advice, and sometimes working with the customer to deliver a new product. And also got a couple of books and video courses with Manning, and also self-published a couple of video courses as well. And recently, I've also started a podcast called The Real World Serverless, where I speak with other people that are building stuff in production with serverless technologies. So continuing on from where we left off there, we were talking about application dependencies. And I think the story here really is that your application dependencies is probably a much bigger attack surface than you realize. There's the things that you depend on directly, but then oftentimes you find that the libraries that you depend on have their own dependencies as well. In fact, it's not hard to pick up any number of mainstream languages and the popular libraries in those languages to find that there's a very deeply nested list of the dependencies in terms of packages. And in fact, when it comes to Node.js, it's such a well-known thing that even if you just have one dependency, you look into your Node modules folder, you see thousands and thousands of folders and dependencies in there. And of course, trying to manually patch all of the dependencies constantly is just not going to happen. It's just too much work. That's why using services like Sneak is really, really useful, which helps you update those dependencies for you. And they have built-in integration with Lambda as well. But however, the thing I found with in terms of updating my application dependencies, that's quite different from updating my OS and applying OS patches, is that whereas the OS patches are usually self-contained and is issued by a trusted entity like Microsoft or Apple, with your application dependencies, they often come with other feature changes or API changes. That means you need to reintegrate with them. You need to test your application to make sure everything is still working. And sometimes can cause incompatibility between your different projects as well. So you've got different, say you've got a micro front end and you've got different versions of React, for example, that may cause problems when you integrate everything together. And not to forget that the sort of weakest part of your security chain is still, so your security is only as good as its weakest link. And when you look at all the different places, someone can potentially attack your serverless application. There's the physical infrastructure that's supported and maintained and secured by AWS. And then there's your application code, there's your dependencies for your application. In the movies, of course, people are gonna just go to the physical infrastructure and try to attack those. They're gonna hang themselves down on wires and then log into applications that they never seen before. But in the real world, there are just so many low-hanging fruits that you can execute attacks against someone's application. Often using things like injection attacks, cross-site scripting, or trying to exploit known vulnerabilities in their dependencies. And of course, people are often the weakest part of any kind of security chain. If you if you haven't watched Mr. Robot, you should definitely go and watch it. Just binge watch the whole thing. It's amazing. But one thing you notice is that most of the hacks that the characters do in the TV series is around social engineering. It's around phishing and targeting the users of a system. And of course, when it comes to our application, there's also the developers for the application. Maybe if someone haven't taken the care to secure their GitHub account properly, and an attacker can potentially get into the application's source code by compromising one of the developers' GitHub accounts. And also, it turns out there's another group of people that are part of our security chain, which can also be exploited, who are the authors of the NPM packages that we depend on. So this happened in 2017, where a white-hat security researcher managed to gain published access to something like 14% of all NPM packages that's available on NPM at that time, which included some of the most popular packages out there like Express, React, Debug, and Electron, and so on. All in all, those packages accounted for over 20% of the total monthly downloads from NPM. So that's a pretty crazy number. That's 1 in 5 packages that you have downloaded could potentially have been compromised because the authors of those packages haven't taken care of securing the NPM account. And when you look into what the researcher actually did in terms of how did he manage to get all that published access, he didn't do anything crazy. He wasn't particularly certificated. In fact, he was using mostly known account leaks from other places. And sometimes, in some cases, he found that the people's NPM credentials was in plain text in the public GitHub accounts. And so he combined some of these known account leaks with some random generation of characters at the end and to suffixes, and able to get access to 14% of all NPM packages. And when you look at the summary, it also doesn't make for a pretty reading, where something like 1,000 up to almost 1,000 developers was using passwords like 123, 123, 4, 5, 6, and password for the NPM account. So clearly we know to do better, and clearly we can do better. And this is just a problem with attitude that maybe we just often don't think about, things like GitHub accounts, things like NPM accounts. And for serverless, for Lambda function, for Lambda, there's a very interesting implication here where if our dependencies are compromised, because when you look at the execution environment for any Lambda function, you'll find some really useful information that an attacker will find very tasty in terms of your AWS assets key and the secret key, session token, and region. Basically, everything, all the information an attacker needs to be able to assume the identity of your Lambda function and access your AWS resources. So to see how easy this can actually be done, I published an NPM package called the "Do Not Download This Package," so where I try to sort of simulate this kind of attack vector. And I clearly, I don't want people to download this, so I gave it a really noticeable name. But to my surprise, within the first week, I had over 200 downloads, which I guess clearly tells you something's not quite right here. So with this package, all I'm doing is I am taking your environment variables and sending it to some backend. Of course, I was really paranoid that someone would actually install this package. So what I did in the end was I had a trigger there as well. So only if, so this code will only run if there's some specific conditions that are met. So I set up an endpoint whereby I am collecting those environment variables, and then I'm looking for things I'm interested in this case, AWS credentials. And then when I find one, then I publish to SNS topic, which in turn send myself an email so I can then grab this and then put it into my console to see whether or not I can actually use these AWS credentials. And lo and behold, yep, I was able to use the credentials to access my AWS account, use and list my S3 buckets, and that took me about 5-10 minutes to actually put together. So this kind of attacks is really easy to orchestrate. And also wanted to test whether or not this is whether the same thing can work for transient dependencies. So again, set it in the package, and again, people downloaded the package straight away, which is really scary that this happens. And of course, still works when you have transient dependencies as well. So not so great, not doing well so far. And turns out there's I was going about this the wrong way. I was going about this the long way around. Turns out there's actually other way that you can attack you can attack the people. You don't even have to compromise legitimate packages. So this happened also in 2017, whereby an attacker who probably wasn't even trying to hide what he's trying to do, basically published a bunch of NPM packages that has got a similar name to real ones. So instead of cross-env, he will publish a package called cross_env, and then someone will accidentally install the wrong package. And in this case, he was stealing people's environment variables, because again, oftentimes we find ourselves putting sensitive data in the environment variables in plain text. And I see people do that with Lambda functions, as well as with containers and so on. Turns out with NPM install, there's also other things that can potentially be done as well in terms of NPM install scripts. So there's also other things that people can do against to your laptop. So it all makes things a little bit scary. And turns out these kind of attacks is not just hypothetical. This kind of attacks happens all the time. And I'm sure Tao can tell you a lot more about the kind of attacks that actually happens in the real world against different ecosystems. Another thing about NPM, I know I'm kind of picking on JavaScript here because that's the language I work with the most nowadays, is that if you look at when you install a new package, you see this little caret sign. It means that when you run, the next time you run NPM install, it's going to install not the specific version you had there, but the latest but still compatible version. So where I install version 1.0.0, the next time you run NPM install, you might actually install 1.1.0 or 1.0.1, which means in between, say, committing my code and testing it locally, and then actually getting deployed, because you're going to be doing a clean install on a CI server, you can potentially install a slightly different version to what you had tested locally on doing your test when you were writing the code. So in this case, Potentially, if your package was compromised and then you just happen to be unlucky, and then when you did a clean install on a CI server, you could have installed a slightly different version, one that might be compromised instead without you even noticing. So one of the things you could do in this particular case is that instead of using npm install, in the CI environment, run npm CI instead, whereby nowadays with npm, whenever you install a package, it would create a package log JSON file. But annoyingly, when you run npm install, it just disregards whatever's in the package log file, and will try to install the latest version. So when you use npm CI instead, it does respect the version that you have in the package log file. So this is how you can get the repeatable builds as well. And of course, this kind of problems is not specific to Node.js or NPM. It's just happen to be the ecosystem that I'm most familiar with nowadays, but it also happens against the .NET and Java or JVM world as well. So what happens now is that the attacker somehow managed to get into your systems, maybe through your dependencies or some other way. So the next line of defense that we have is using IAMs to control basically who can invoke your function, but also importantly in this particular context, what can your function access? And this is where the principle of least privilege is your best friend. And it's basically it means exactly what it says on the tin in terms of basically restricting your functions to access to have the least amount of permissions and privilege it needs to do its job. And the same applies to networking side of things as well. So one common mistake I see people make is that they think, okay, right, I've got everything inside a private VPC and public VPC for things that are public facing, and I'm using VPC peering so that you can the stuff that's in the public VPC can talk to the resources that are in the private VPC. And usually you've got this this thing whereby everything that's inside the public everything that's inside VPC is fully trusted. But in this case, imagine if an attacker is able to execute some kind of injection attack and can potentially steal information from your application, or maybe in this, like we discussed, potentially it's not your application that's compromised, but one of its dependencies, in which case attackers can steal data from your application, even though it's protected and sitting inside a VPC. In fact, I think nowadays we're seeing more and more cases where AWS credentials are being stolen and used to do Bitcoin mining. And we'll talk a bit more about that a bit later on. There's some sort of things you can do to help really mitigate or at least reduce the risk of Bitcoin jacking. I forgot the name of that, but I think it's something like Bitcoin jacking or something like that. So when you consider that AWS services like Lambda, DynamoDB, they're always publicly accessible, but you can control access through IAM. So in this case, even if it's public and not sitting in one of your VPCs, it's still nice and secure. However, the same risk that we discussed still exists there, whereby our application can be compromised through its dependencies. So this is where Prisma Cloud from a Palo Alto network, but also I'm sure Checkpoint has got similar offerings as well, whereby they have some runtime component that can block those attempts to communicate with public internet. So if someone have compromised your application through maybe one of the dependencies and try to steal your AWS credentials, then those runtime protection can stop those communication from going out, from leaving your function and going to attackers' malicious endpoints. You can also achieve similar things using VPC and using network ACLs and things like that. But of course, those takes a lot more effort for you to actually set up and maintain and keep up to date. So if you have EC2 instances or ECS containers that are sitting inside your VPC, and if they're compromised, then they can still allow attackers to access all the sensitive data you have, all the in your AWS resources that are sitting within your VPCs, which is why a much better way to approach security for your application is what is nowadays called the zero trust networking. Essentially, for every single API you have, you want to implement authentication and authorization. So basically, trust no one with whether or not they are sitting within your sort of trusted network environment or not. Just don't trust anybody. Always implement authentication. So very commonly, we will create the APIs using API Gateway and the Lambda. And the common question I get is, well, API Gateway supports all these different authentication methods. Just what should I use for my application? So I wrote a blog post recently to walk through the different options you have. Essentially, I think if you're building some kind of a SaaS application where you want to give access to some other third party, but you want to also at the same time rate limit them as well, then you should be using API keys together with the usage plans. But if your API is going to be used by end users directly, then if you're using Cognito, then you should use a Cognito authorizer as the authentication method. Otherwise, you can also use a custom Lambda authorizer function to integrate with other user management services like Auth0 and things like that as well. Alternatively, you can still use Cognito authorizer, but integrate Auth0 or Okta or other providers with Cognito through SAML. And for internal APIs, APIs that are only supposed to be accessed by your own services or other components like EC2 instances or ECS containers, then you should be using AWS IAM instead. And the thing that you probably shouldn't do is you shouldn't try to do authentication and authorization within the Lambda function itself, because in this case, if an unauthorized request comes through, it's going to go through API Gateway and it's going to go through to your Lambda function. And in this case, only at the Lambda function, then do you realize, oh, this is an invalid request, we should reject it. And in that case, you can end up paying for the API request for API Gateway as well as for the invocation for Lambda functions as well. Whereas if you're using one of the authentication, one of the authentication and authorization methods available for API Gateway, and you can reject requests at API Gateway level, then you won't have to pay for those unauthorized or invalid requests. So another thing you got to look at is in terms of applying the principles of least privilege is minimizing what your functions can access. And the key part of this is making sure that you have tailored role for every single function. So if you've got an API with lots of different endpoints and every endpoint is handled by a single Lambda function, then those functions potentially going to be doing different things. Some may need to read from a DB tables, other may need to do a write. So every function should have its own IAM role and that are tailored to just what that function needs to do. So depending on the deployment framework you're using, the server framework, for example, doesn't support this really well out of the box, but there are plugins like the Serverless IAM roles per function plugin that basically you do exactly that, whereby for individual functions, you can configure what IAM permissions that function would have. Of course, the downside of this approach is that it does take a lot of developer discipline. And we know that if you need to depend on developer discipline, then you are going to fail. And we need tools that can automate a lot of this for you. And again, this is where providers like PureSec and Protego comes in, and both of them has been acquired, as Tao mentioned just now, that the Protego been acquired by Checkpoint, and PureSec has been acquired by a Palo Alto Network. Both of them provide the services and the tooling that can automate some of these for you. Another thing that you often hear about is that when you're writing Lambda functions, they should be ephemeral, they should be stateless, which does mean that you end up using a lot of different services, external services, to keep hold of a user state. And it's important to make sure that those data are secured and encrypted at rest as well as in transit. The good news is that pretty much all the AWS services that handle user data now support server-side encryption. So this started with S3, with S3 server-side encryption. There's a couple of different options you have there, and RDS supports that now as well, and so there's RDS, DynamDB, and the QLDB supports server-side encryption as well. And again, you also so you want to do all of that, but still want to make sure that you allow your function the least amount of access possible, which is a very, very key part of securing a service application. So, and one benefit of using Lambda is that you don't pay for functions that are just that you don't use. But it also means, on the flip side, it also means that sometimes it just less incentive to delete old functions that are no longer used, which potentially leaves functions that are out there that are sort of old and using old versions of dependencies that are not being maintained actively, sitting around in your environment, potentially still presenting themselves as an attack surface. So as part of the sort of best practices that's recommended by AWS, they do ask you to delete old versions of your functions or old functions that you no longer use. What I find is that in practice, this is a lot easier said than done, especially in a large IT organization, whereby identifying ownership for different components is quite challenging. But when it comes to having individual functions, that's even more difficult, especially when time to figure out whether or not function is actually being still required, or is it just not being used actively because it's only used for so disaster recovery scenarios, or using for fallback cases, for dealing with failures that just doesn't happen often. So one of the things that I find really helps in terms of helping you identify ownership really quickly and easily is that every function should get tagged with a number of useful tags, such as the name of the team, maybe the cost center, which really helps you in terms of cost tracking as well, but also maybe the business area or the name of the author as well, if it's owned by a specific individual within your team. And then there's also this whole thing around now service attacks with Lambda functions. With serverless, you're more likely to survive the now service attack because the system is just more scalable by default. However, you do end up paying for them. So which is why often nowadays we call denial service attacks in the service world denial avoided attacks, because well, you may be able to scale force your way through that, but you end up paying through the nose for those attacks, which is why it's still important for you to use things like a WAF and configure them on API gateway or on the cloud front. And specifically, you want to use set up rules for RAID-based rules against single IPs. These are useful and effective against naive attacks that originate from a single IP address, but they're not effective against the distributed attacks that come from many APIs, IP addresses. Which is why, on top of that, you still want to set up a throttling API gateway, which is enabled by default for REST APIs, but not for HTTP APIs. So however, with REST APIs, one thing to keep in mind is that you want to review the default setting, because the default setting for API gateway REST APIs is 10,000 requests per second, which is way more than most API endpoints needs to handle. And also the 10,000 requests per second, that's also your regional limit, which means potentially as an attacker, all I need to do is launch an attack against a single endpoint, a single publicly accessible endpoint, and I can potentially take down all of the APIs in the entire region, because the default throttling limit on API gateway is also your regional limit as well. In terms of protection against the denial of service attacks, AWS has got a few other things in up their sleeve. There's AWS Shield, which protects against the network layer flooding attacks and things like that, and it's available to everybody, just for free out of the box. But if you want more protection against that, then there's also AWS Shield Advanced, which very usefully, it gives you access to a specialized team within AWS, so that if you are under attack, then you can reach out to this team to help you, walk you through how to mitigate that attack. And also it's got some protection against the extra charges that you incur for things like ELBs, CloudFront and Route 53. But unfortunately, that protection doesn't cover things like API gateway and Lambda costs. So one of the things that you also want to think about when it comes to protecting your Lambda functions is that you don't want to have because you're paying for Lambda invocation, but also for the duration of your function as well. So in cases where your function potentially are under attack, or maybe you are being say someone is executing regex now service attack, then the potential can cause your function to run for a very long time. So every single request end up taking longer and therefore cost you more. So one of the things you can do to protect yourself there is just be sensible when it comes to applying your timeout for your function. Don't just throw 5 minutes or 15 minutes on every single function. For API functions, for example, API gateway has got a hard timeout or integration of 29 seconds anyway. So even if your function runs for a whole minute, it doesn't really matter, because API gateway will have timed out by then. And so for API endpoints, typically you want to use a really low timeout, like 3 or 6 seconds. And also make sure that you've got a good alerting setup, so that when there's a high number of 4xx or 5xx errors, make sure that you get alerted quickly so that you can investigate what a problem is. So I touched on the Bitcoin and how people are now trying to steal your AWS credentials so that they can do Bitcoin mining on your AWS account. Right, the name I was looking for is cryptojacking. That's what it's called nowadays. And it's not hard for you to find lots of articles on the internet of people and developers like you and me who has been hit by this, whereas maybe you just accidentally put your AWS credentials into a public GitHub repo, push a commit without realizing, and then bad things happen, and next thing you know, you wake up and you got a massive AWS bill because someone has used your credentials to do Bitcoin mining. So when I was investigating how to sort of mitigate this specific attack vector, I found that there's a really good way to do this is using Git pre-commit hooks, and then basically run a script and trying to find out anywhere that you have plain text that looks like AWS credentials. Another thing I heard from my contacts within AWS is that when this kind of cryptojacking happens, Sao Paulo and I think Tokyo and a few other regions are the hotbeds for attackers to launch EC2 instances, because for many people running on AWS, they are not using those regions. So when when attackers create EC2 instances in those regions, chances are you won't notice. So something you could do is you can monitor those activities in regions that you're not using CloudWatch events. And you can also have CloudWatch events or EventBridge in this case. Basically, it's got rebranded to collect all these different events from different accounts, so that you have one single account where you can set up this kind of monitoring. And if you got this multi-account setup, in fact, an even better way to do this is to just disable those regions in the first place. So if you're using AWS organizations, then you can set up service control policies or SCPs, in which case you can disable access to specific regions or even specific services within those regions. And one of the best tools I've found to manage this, especially if you want to use infrastructure as code, is this open source project called AWS Organization Formation. Essentially, it's extension. Well, not extension. It's a tool that basically allows you to use CloudFormation-like syntax to, provision and manage your entire AWS organization, including configuring service control policies like what I have here, whereby I know for this project, I'm only using US East 1, so I'm just going to disable all the other regions except US East 1, except for a few services that are global, like CloudFront, IAM, and Route 53, and so on. So I actually did a webinar on this with the creator of the org formation recently, so you can go and watch it on the YouTube afterwards. And the last thing I want to touch on in terms of some of the things you want to think about and to secure your serverless application is using this concept of a bulkhead, which is used by chip makers to compartmentalize a whole bridge, so that if one part of the ship has had a breach, then it doesn't take down the entire ship. And this concept has been popularized in the microservices world by Michael Nygaard in his book Release It. So in terms of bulkheads, there's several things we could do. We can apply least privilege principle coupled with having per function policy, so that if one function gets compromised, because every function's got its own IAM role. So again, you're compartmentalizing that bridge to just what that one function is allowed to do. But again, also you can apply that to the whole AWS account as well, whereby if you have multiple AWS accounts and somehow someone got access to your dev account, at least they won't have access to your production accounts, the user data, which again is a good reason for you to have separate accounts for different environments. And that kind of covers everything I wanted to cover with this talk today. As a quick recap, it just goes through some of the things we've covered already. Think about your application dependency is probably a much bigger attack surface than you realize, and that the risk from OWASP top 10 is still very much applicable when it comes to the security of your serverless application. And wherever possible, you want to sanitize your user inputs, but also sanitize your output as well, so that you don't leak data that your application shouldn't return. In terms of the sort of security of your Lambda functions, apply the principle of least privilege and give every single function its own IAM role and tailor that permission to just what that function needs to do. And don't forget, you've got lots of data spread out in different data services, and you want to encrypt them at rest, but also encrypt them in transit as well. And when you have Lambda functions that aren't being used, delete them proactively. And nowadays, remember, denial of service attacks is still a thing, it's still a problem because it can cost us problems in terms of our AWS account, how much we pay. The AWS Shield, however, it doesn't cover the cost for Lambda functions. And also, take care of your AWS credentials. You don't want to be a victim of cryptojacking, end up with a big bill for your AWS account, and then have to find some way to get those money back. And finally, compartmentalize your environment using separate AWS accounts. And remember, people are still the weakest part of any security chain. So if you want to learn more about AWS Lambda, just also check out my video course as well, lambdabestpractice.com. And I'm available as a consultant. So if you want to talk to me and see how we can work together, check out my services at theburningman.com. And with that, thank you guys so much for your time, and stay safe. And I guess we would take some questions now.
Yeah, hey, Jan, thanks very much. Great talk. So what we're gonna do now is that people can ask some questions over the chat, and Jan could answer a few of them. We'll have a few minutes for those, maybe 2, 3, 4 minutes. Then we'll have a few minutes break until we reach out around hour, and then Barak will give us a talk. Just a quick thing. So Jan mentioned the OS Top 10. This is if you aren't familiar with it, it's probably the go-to for application security. And of course, we still have code and applications, so application security is still relevant here. I was I'm leading, and I created the OS Serverless Top 10, which is a project that aims to take the original Top 10 and convert it to the serverless space or architecture. You're more than welcome to check it out. Yeah, other than that, I completely agree with you. Let's see if we have some questions.
So there's a question here from Fernando. Any thoughts on security considerations for custom runtimes on Lambda? I guess with custom runtimes, that's a bit tricky because I would say don't use custom runtimes unless you've got a really good reason to. But they do have some really interesting, I guess, potentials for security. With this company called NewWeber, based out of Israel, and one of the things that they do, so basically they offer this Lambda compatible, API compatible offering for functional service offering. And one of the things they do is they don't give you the real AWS credentials in the environment variables, but instead what they do is when the request goes out, they capture that and then they swap it out with the real one. And the credentials that's in the environment is actually just honeypot credentials, so that they know when someone is trying to use those credentials for real. So with custom runtimes, one of the things that potentially you could do is apply a similar thing to basically secure those, because one of the things that you really can't do with the Lambda runtime is that those AWS credentials is going to be there in plain text, whether you like it or not. However, with a custom runtime, one of the things you could potentially do is to secure those credentials is to you basically sort them out with honeypot credentials, and then you basically apply similar idea and capture those requests to AWS services and then swap them out live. But other than that, the custom runtimes, it means that some of the security for the sort of for example for the language runtime itself is now up to you. So it's additional security things that you have to take care of yourself. For example, if you use, so there's another custom runtime for Node.js, which is supposed to be more secure than the official Node.js runtime. I haven't tried it myself, but I can find out for you and send you some more information about that. I don't know about if you've got some thoughts on that, Tao. Have you guys done much work with custom runtimes?
Yeah, I mean, we haven't seen so many custom runtimes. I think that one of the reasons to move to serverless is to take this out of
Yeah.
your mind. I mean, you don't need to secure your runtime anymore. It's just about you give it away to the provider, and using custom runtimes really bring it up back to you.
Yeah.
Yeah, so I know you also mentioned protection against denial of service and things like that. I know I remember that AWS just, I think in the past 2 days or so, published that they probably blocked the
biggest,
probably biggest, yeah, DDoS
yeah.
stack. So if you're running on their environment, you don't have to worry about those things, right? This is one of the reasons to move.
Right, okay. I think Fernando is asking because I think he's using R.
Yeah, I can see.
So it's yeah, unfortunately, there's just no way around that apart from using custom runtime. So one of the things you notice with the Lambda runtime is that there's a lot of things that are just blocked by default because they don't let you execute a whole bunch of different things against the Node.js runtime, for example. But if you want to so do the same thing yourself, then that's up to you to do that.
Yeah, last note maybe on that. So I think, and you mentioned also the weakest link is always the developers or the people. Right?
Yeah.
So I think the best way is to automate. So also for things like custom runtimes, you would probably want to find some kind of either a solution, like, I don't know if it's a commercial or not, a solution that would automate anything possible within your environment. There are some maybe some possibilities or some options to get some security that doesn't really need or take the runtime into consideration, because they are all security resources that they're all resources on the cloud, on AWS or any other provider. So you could get probably a different aspect of security of the not on the runtime itself, though.
Yeah, I think well, both Protego and Prisma's Cloud provide runtime monitoring and all kind of a solution for service applications as well. So maybe also another angle potential to think about to use those services.
Yeah, some problem with the runtime protections are that they depend on the runtime. So if your runtime is unfamiliar, then we'll have to write the specific solution. Another thing that you mentioned, and then we'll move. We'll have a 5 minutes break. So you mentioned a lot of protecting your APIs. One of the maybe interesting thing, or in terms of security in AWS, is that it's not all APIs anymore. It's not like a server, right? That you can just it's APIs, but not really REST APIs. I've been to Black Hat Europe in last December, and I talked about an attack that is through Alexa. So you can't really protect your APIs behind Alexa, right? Because your code runs behind an API that it belongs to AWS, and you don't have a REST API that you can protect with API keys or whatever. So you'd actually have to find or to think different about how you protect your resources in the cloud.
Yeah, and you also have a similar thing as well with a lot of like IoT core, for example. If those are messages coming directly from devices to IoT core, yeah. And anyone can make those requests if they just see what you're doing over the network. Or sometimes loads of cases whereby there's a large object we can't have API gateway receive that, so we give you a URL to upload to S3 and then we process it. So again, that's another way to sort of trigger your function without going through APIs.
Yeah.
But yeah, it just I guess the thing with serverless is that it opens up so many doors, so many different ways to build systems, which means you can build more complex, more interesting systems. But it also means that there are more ways you gotta have to protect yourself from a security point of view as well.
Yeah, I think that we just need to wait for more solutions to be adopting the environment. So you'll probably have the same eventually. If it grows as it's supposed to be or predicted to be, you will have a set of solutions that covers also serverless in all its aspects eventually, I guess. All right. Thanks, Jan. Thanks very much.
Thank you, guys.
All right. We'll have a 5 minutes break and then we have up Barak.
Cool. See ya.
All right. I think we can move on to the second talk. We have with us Barak. Barak is the CTO of Bridge Crew. Barak can introduce himself and give us his talk about about static analysis. for serverless.
All right, cool. Thank you, Tal. It's great to be here. So hi, everybody. My name is Barak Schuster. I'm co-founder and CTO at Bridgecrew, a cloud security startup for static analysis and runtime analysis of your cloud infrastructure. As a hobby and also as part of my job, I'm an open source contributor to various security projects around AWS, Google Cloud, and Azure security, and also projects around the security of infrastructure code. So if you're about Kubernetes, Terraform, CloudFormation, Serverless, or any other kind of DevOps security framework, I'm really up for a talk. And on my previous role, I was a data scientist and software architect in a machine learning company that was acquired by RSA, doing some security research about network telemetry and OS telemetry. So if any of those topics interest you, feel free to direct message me at Twitter. It's Barak Schuster case. So in today's talk, we'll do a little setup of what is a cloud misconfig that can happen on serverless function. Jan talked about some of those at the previous talk. We'll cover the topic of how to analyze a runtime environment and how to analyze a static environment, what's the differences and how to choose those. So basically, what are the general risks on infrastructure in the cloud? There are obviously more risks for non-compute resources like data leakage, but on Lambda perspective, it's really about having an endpoint that can be publicly accessible without any authentication or in an unsecured protocol, having an overprivileged entity and the Lambda that will enable a malicious actor to access data points or corrupt the infrastructure, access to unencrypted stores, plain text secrets that leads to crypto mining, as Jan said, and vulnerable packages in those microservices. But really, where do those misconfigurations come from? And the answer is most of them or some of them comes from the open source, while others can come from your internal GitHub repository or stuff that you're doing yourself and you haven't noticed that is bad. And it is not because you use serverless or because you're using infrastructure code. Infrastructure as code actually is an enabler to fix most of those issues, since for the first time on serverless YAMLs and infrastructure code, all of your configurations are version control and can be reviewed by peers in a pull request. But the thing is when you're developing a new feature, you just want stuff to work usually. So you put a star in your IAM credentials. You just put a definition of S3 bucket, and you really don't have the time and expertise in a lot of times to put the security minds into it. So it's not that we don't want to build the security infrastructure, it's that it's just not always in the main focus of us, because we need to deliver customer value as application developers. So what we've tried to understand at Bridgecrew using an open source tool is where do those open source modules come from and how does those look like? So we open sourced a tool of static analysis for infrastructure as code called Chekhov. And what we've done with Chekhov is we started to scan different repositories in the internet, in GitHub. And what we have discovered over infrastructure as code templates is that 48% of those 1,800 templates were misconfigured. It's quite a lot because those modules had 23 million downloads, meaning those are EC2 instances, serverless Lambdas, S3 buckets that those Lambdas access that were provisioned in some point in time. They might have been already fixed, but at some point in time, we had a lot of provisioned resources that had some kind of configuration issue. And the different configurations issues can be lack of logging, lack of backup and recovery, lack of encryption, sharing PIDs in Kubernetes, for example, or root access, networking issues, general security issues like forgetting the access keys in plain text, and also overprivileged issues. And what we try to understand is over time, how does those issues look like? And it appears to be that the pace of contributing new modules is growing up, which is great. Contribute to the open source, power to the people. But when people are writing more code, there is actually more misconfigs. And during COVID, actually, at this period of time, we had a spike, probably because people had a lot of time and were much more productive working from home, creating a lot of more new open source modules for infrastructure code. But with those, they had like a ton of new misconfigs. So how do we find a bad config in our environment? There are actually two ways. For Lambdas, there is a very cool project by the security team of Skyscanner, a flight company, that does API polling to identify drift from best practices. The same best practices that were mentioned before, which is making sure your Lambda is least privileged, making sure that you don't have plain text secrets, and that the API endpoints are public only when they need to be, and in the way that they need to be. And also the connection to the different resources that the Lambda is accessing, for example, those S3 buckets, are defined in a safe manner. So the security team of Skyscanner have decided to open source a great tool called Lambda Guard. How would you deploy usually Lambda Guard on a production environment? What you will do probably, you can do that with Lambda Guard or Prowler. You will deploy Lambda Guard probably on an ECS cluster, and you will scan every 1 hour, 2 hours, once a day, by a specific cloud trigger, your different AWS accounts for various issues on Lambdas that are talking to different resources. What AWS would recommend you is to stand up a security audit account to scan each and every of your multi-account environment. So if you have dev account, QA account, staging, and prod, you should have another centralized security account that, using cross-account role, will access those resources using a security auditor role, the standard of AWS, and will query those different APIs by described actions for the security status. So let's take a look on how does that look like. Let me share a terminal in a sec. All right, so over here, I have a Python environment. In this Python environment, I would run pip install or pip3 install Lambda Guard. The thing that it will do, it will just download the standard pip package of this great project. I've already did that. So what the next thing would be, let's run Lambda Guard -- help. All right, so Lambda Guard can scan a specific function. If you have an ARN of a function that you'd like to check, it has the ability to have a list of ARNs that you'd like to check, or it can scan the entire AWS account by a specific profile, or specific access keys and secret, or a specific region. So what you would usually do, so on the file system, you probably have, if you have AWS CLI, credentials deployed at AWS / credentials. Over on that file, you will deploy your access key and secret. And what you will be able to do is writing Lambda Guard -- profile, and I have a defined profile inside this file, demo. And it will just start scanning your AWS environment. Obviously, your environment is probably called dev, prod, staging, or in the name of the AWS account. And how does a result looks like? It will just generate this beautiful report on your local host, on your local folder, where you have security issues defined by different severities, low, medium, and high, various sets of triggers that is connected to those lambdas in my environment, various runtimes, and various resources that are connected to this lambda. So over here, I even have multiple versions of Python and Node lambdas, while some of the lambdas have a deprecated version of Node, which has obviously security packages issues. And from security standpoint, I can see that I have here this lambda that is missing resource-based policy, meaning it can access every resource in my AWS account, which is obviously an overprivileged lambda. Another one that is publicly accessible without any conditions, which is bad for those specific S3 buckets. And this specific issue is also interesting. This lambda can attach, so this lambda create production readDB can attach a role policy, meaning this lambda can grant access to other lambdas, which makes the problem even worse because they can add more and more issues to different ones. And we have this issue repeatedly across lambdas in my environment, which is super bad because it makes a multiplier of access points for attacks over my environment. Not only the lambdas, but also the resources that are attached to those lambdas or the lambdas have permission to modify. Also, some of the lambdas has in their serverless definition, CloudFormation that defines other resources. So if you define inside the serverless framework YAML an S3 bucket, you should define encryption on top of it. Otherwise, you have an unencrypted bucket, which is even if an encrypted bucket, even if public, you'll get a 401 response that you cannot read this data. But if it's not encrypted and public, everyone will have access to this data, and obviously that can be super sensitive. All right, so let's take a look on how should we deploy Lambda Guard. So we can run this pip install and configure those access keys, and from that point forward, that's it. You can obviously also integrate that with SonarQube if you're running SonarQube as part of your deployment process. So after provisioning those resources, Lambda Guard can scan live resources after the fact and help you determine whether you have a vulnerable or misconfigured resource or not. So that was nice. We saw how to scan a live environment and get notification. The next phase would be probably to connect it into a remediation Lambda. And for each alert that Lambda Guard generates, start to do changes to your environment. That can be, right, every time I'm getting an unencrypted bucket, let's turn on encryption. And every time I'm seeing a public bucket, let's turn on private access ACLs or private restrictions. As for Lambda perspective, what you can do if you, for example, identify Lambda that have plain text access keys, you can ask if you should allow that to be deployed into the next environment from dev to staging to prod. So let's say that I'm finding these issues in my production environment and I'm fixing them. And then I have more engineers that are working on new Lambdas and more issues come back. It's an endless chase between security practitioners and engineering practitioners to write new code that works and it is secured. And finding those issues after the fact is a lot of times too late, either from security incident that could have happened in that time, but also chasing other engineers with Jira tickets on issues that you find in their production environment is just very not good use of your time. So that's why we decided to open source Chekhov that I started to talk about. It has a bunch of 100 built-in checks. Actually, today it's more than 300 built-in checks that is managed by the community. People from different companies like Salesforce and Capital One and AWS are contributing more and more checks to Chekhov across various infrastructure code frameworks. It's Apache 2 license, so you can use it for free. It's written in Python and very easily extendable and integrated to your CI/CD pipeline. So how would an architecture where Chekhov runs would look like? On every change and every commit to a pull request, you can run Chekhov on your GitHub Action or Jenkins or wherever you're doing your build server CI pipeline and run a set of infrastructure tests. Those infrastructure tests will either reject or approve your infrastructure code changes. And from there, you can go through the usual deployment process of either applying lambdas through serverless deploy, Terraform apply, etc., into your production environment. So let's take a look on how does that look like on a real terminal. Right, so over here, I have a directory where I have some failed serverless files. Let's take a look on how they look like. It's a standard serverless YAML. So serverless is an amazing framework where you can just define a Lambda with the Lambda environment with a very low amount of configuration code in YAML. So over here I have an AWS Lambda of Python 3.7 with an environment variable in provider level, which means that is defined for each and every function. Some resource blocks that defines S3 bucket, and a function here with some IAM role statement. So this function, the serverless YAML, is failing in my CI/CD pipeline because it has a bunch of security issues, like a lot of security issues, meaning it doesn't really matter what code is inside it. It has admin access to environment. It has access to unencrypted bucket. But let's see how I can check that without telling you what other issues there are there. So what I can do is I can either brew install Chekhov, and there is a guide to do that here. You can just tap into Bridge.io and install Chekhov using brew, or use pip3 to install Chekhov on your pipenv environment. So let's say that I pip installed Chekhov. What's then? So Chekhov has a set of commands that can tell you what should you scan. So the very obvious one would be, let's scan a full directory of serverless YAMLs and other infrastructure code. So I'm going to scan this failed directory. So I'm going to write Chekhov -- directory failed. And what Chekhov did is writing a lot of issues. We have in a single serverless file with a single function, 11 security issues. Let's zoom in about it. So we have one past check, which is there is an S3 bucket that does not allow write permissions for everyone, which is good. Not everyone can write into my bucket, which limits denial of billing capabilities, and in some cases also injections option. But this bucket is not encrypted. So I have a bucket defined under the resources block in the serverless YAML between lines 15 and 21 that has a bucket without any encryption block defined. And it allows also public read to everyone, does not have logging enabled, and a bunch of other issues. And from my IAM statement point of view, Chekhov have identified that I have admin access for my function, for my Lambda that is defined here. And I also have plain text access keys named example something. But in real world, that could have been actual access keys on my production environment. And here is another variation of an admin access. So what am I expected to do with this information? So just before provisioning this, this serverless YAML, what I can do is I can write Chekhov -d and scan the data directory. And when I get a failed result, what I can do is just start to fix those. So I know that I don't have encryption, for example, turned on for the bucket. What I can do is let's add the encryption block. So over here, I've added bucket encryption with AES algorithm. Let's try to scan again and see if we get a different result over encryption. And yay, we have that. We have this check that was failing before. And now I know that my code, my serverless code is valid, and I have this serverless encryption enabled. All right, let's go back and try to understand how the rest of the issues looks like. So as a developer, I can run Chekhov before provisioning the code into production. But that's a very manual task. So how can I do that automatically before every commit, before stuff are arriving GitHub into the provisioning pipeline? Let's try to integrate Chekhov with a pre-commit hook. Right, so over here I have a vulnerable by design project named TerraGoat, which is also open source, and you can feel free to play with it and download it and see some vulnerable infrastructure as code stuff. So in this project, I have created a new file, a serverless YAML file that I'd like to commit into my GitHub. Let's take a look how this file looks like. So pretty similar to the previous one, with encryption not enabled, and with some access keys and admin credentials. On the Git status, I see that this file is pending for commit. Let's try to commit it. So what Chekhov is, what Git pre-commit hook is doing, it is running Chekhov on every commit just after the commit that I did with the unstaged file that were changed, which is this serverless YAML file. And it runs Chekhov. And it fails for various reasons, among them the serverless YAML file. So how do I configure a pre-commit hook? What you need to do is to have pre-commit installed, which is pip install pre-commit, and have a pre-commit config YAML in your GitHub repository. In this pre-commit config hook, you can say, hey, run every time you run branch master, or take the Chekhov from branch master and run it every time on the changed files. So if you have change files like those two, it will run Chekhov against them and will prevent the commit from ever happening, which is cool. You can prevent stuff from happening before taking them for even a code review. which saves time. So what's the next phase? Let's say that you don't want to deploy a pre-commit hook and on each and every endpoint, in each and every developer's endpoint. What you can do is you can use a GitHub action or integrate it with Jenkins or every other CircuitCI or every other CI tool. And you can have Chekhov scan your infrastructure as code repository on every pull request. So it will run the Chekhov job on every change. So how does that look like? The Chekhov GitHub action will actually create an annotation on each and every code block that you've defined, whether it is serverless, Terraform, or any other infrastructure code framework. And it will fail your build. And it will tell you, hey, you need to fix those security issues in your infrastructure before it can be merged into the master branch, which represents production. So how can you start using that? Chekhov actually has today, this is an old screenshot, it has more than 500,000 downloads, and it is being used a lot among great, amazing companies. So you can start using it at bridge.io/Chekhov at GitHub, and check it out and tell us what you think. So going back to some of the issues that also Jan mentioned, but the comparison of catching those misconfigs either on runtime, on Lambda config analysis using API polling or static analysis, when should you use each one of those? So Lambda Guard, which is a runtime Lambda config analysis tool, is on the deployment mechanism, it is centralized in your security account. And it is managed usually by your security engineering team. It is bad because usually that's a one-to-many problem. You have like a huge workload on your security engineering team with a lot of security issues. Having another tool that they need to maintain and another tool that they need to create alerts and JIRA tickets to the engineers on top of can be a headache. I would prefer a distributed tool that runs static analysis that people can be aware of when they're developing new code or submitting a PR. The good thing about it, it's part of the production monitoring, meaning it is aware of the real state of the production environment. Even if some of your Lambdas are managed manually or not via your infrastructure code, not via your GitHub, let's say that someone edited manually an admin, an SRE, manually modified an environment variable, only the Lambda Guard will be aware of that because it's not managed as code, and Chekhov is only aware of stuff that are managed in code. It is scalable across multiple AWS accounts. You can have one security account querying hundreds of AWS accounts with cross-account role. It takes several minutes to run and identify, and it addresses the compliance, SREs, and security teams. Static analysis tool is distributed by design as part of the CI/CD pipeline. It is scalable across multiple repositories if you have. The downside of it is that it is not aware of the production state. If someone have done a manual change, you wouldn't know that from Chekhov, for example, or any other static analysis tool. It takes several seconds to identify as part of a parallel job in your CI/CD pipeline. And it addresses the developers. Each and every developer that is writing a new Lambda can get a very fast feedback on whether he or she did good or missed something. So what should I do? Should I use a static analysis tool or runtime analysis tool for my cloud serverless environment? Yeah, the answer is you should use probably both. And because you want to get the best of both worlds, both production state monitoring and doing distributed security reviews. And the architecture would look like, hey, let's deploy Chekhov as part of our CI/CD pipeline to prevent from new stuff that are managed in code to arrive to production. And let's have Lambda Guard as a second line of defense to scan our production environment. That way, you will have both awareness and alert and remediation whenever a resource is being changed directly on the production account, and also awareness of each time code is being changed and an automatic review on top of that. To get started with an automated pull request review, what you need to do is just go to Chekhov action at GitHub, bridge2io/Chekhov and you can get this project from the marketplace. You will just need to configure a Chekhov action to run. You can actually also configure it to skip some of the checks by the check IDs that you'll see on the CLI output. And you can display only fail checks if you'd like. So it's pretty simple. And to start playing with a vulnerable environment, if you'd like, but please do not provision that into your production account, you can go to bridge2io/Terragoat and apply a vulnerable by design Terraform infrastructure across your AWS and Azure environments. So keep in mind that when doing that, like I did to apply LambdaGuard, make sure that you delete this environment at the end of it and dispose the account, because it is vulnerable by design and has a bunch of public stuff. So never run it on an important workload account. So to apply, just run Terraform apply, and to remove all of those resources, just run Terraform destroy. It has more than 80 vulnerable resources across 2 clouds. And as for Chekhov, it will scan for, let's see, what Chekhov IO. The number is growing up because the community is doing a good job, and also the engineering team at Bridgecrew. So you have 365 best practices checks across infrastructure as code that are in Apache 2 license, and you can just run across your serverless and Kubernetes or any other environment. All right, so now would be a good time for questions.
All right. Thanks, Barak. So
Thank you.
Looks like a great tool. How long do you have it available?
So we've released it last December. So it's 6 months.
Yeah, 6 months now. All right. Great. I completely agree with you. I think that one of the ways to properly put security is shifting left as left as possible. So having a tool that can give you security before anything even steps into your cloud is, I think it's a great idea.
Thank you.
Are you, with this tool, are you trying to reach more and more platforms like Serverless and Terraform, and getting requests from people to?
Yeah, definitely. So we have like, so currently there is Terraform, CloudFormation, Kubernetes, and Serverless, and we had a bunch of GitHub issues opened on Azure resource templates as another requirement. And also Ansible as a framework that should be supported. So we're working on adding those and contributing it back to the community.
All right, great. Anyone has questions for Barak? All right. Okay, Barak, thank you very much. How long is Bridgecrew? I think it just went out of stealth just recently, right?
Yeah, so we are in production for more than a year with beta customers, and we just came out from stealth last March. And it's Breachcrew is free for start. So if you'd like to use it, go to breachcrew.io and get your production environment and infrastructure code monitored.
All right, great. Okay, so thank you very much, Barak. And we're a little bit early. We'll have Rob, our third speaker, coming talking soon. Let's have 5-minute break and then come back for Rob's talk. Okay, thanks again, Barak. Okay, so we'll be back in 5 minutes with the last talk. All right, let's continue. We have with us Rob Richardson. for our last talk for today. Just last thing before we start, Barak mentioned before TerraGoat, another vulnerable by design project. I don't know if you're all familiar, but I also created the OS serverless DVSA. So it's a damn vulnerable serverless application, and it's open source over GitHub. And you can go and install it with just 3 clicks from the repository, and then you can start practicing your security. There are some videos about how to do things, documentation, presentations. You have the lessons where you can actually learn about the security issues and how to find them. So, and that's of course open source. You're more than welcome to install it and try. Just one word before you do not install it on any production environment. That could end up in a big mess. Okay, so next, Rob, to you.
That sounds awesome. Step 1, try the vulnerable by design system in production. Step 2, lose production.
Step 3, find a new
Panic.
job or get out of jail.
Yes. Okay, so we're going to talk about continuous security by design. I love how each of the 3 of us have kind of taken a different approach to a similar topic, and mine will be no different. We're going to talk a lot about building security into our DevOps process to do interesting things. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. You're going to look on my site tomorrow, next week, next month. In about 3 months, you may get tired of pushing refresh over and over again, and you'll email me. In 6 months, I'll definitely reply and say, no, I'm going to definitely post the slides on my site tonight, which is why they are on my site right now. You can go to robrich.org. You can click on presentations here at the top, and here is continuous security by design. The slides are online right now. Feel free to follow along. Feel free to get ahead, heckle me about the things I haven't said. This is a lot of fun. While you're here, click on About Me, and you'll get to this page that starts talking about some of the things that I've done. I'm a Microsoft MVP. I'm a friend of Redgate. AZ GiveCamp is particularly cool. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for our next one. Or if you'd like a GiveCamp in your area, reach out to me by Twitter or by email, and let's see if we can get philanthropy installed in your community as well. Some of the other things that I've done, SQL Source Control Basics, minus Chapter 8. That was a lot of fun. I was a core contributor on the Gulp team in version 2 and version 3. Sorry. I do training on Docker, Kubernetes, Node, and other things. So if you'd like to, reach out to me there. One thing that I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So that's my claim to fame, is my .NET Rocks mug. So let's dig into continuous security by design. We talked about this guy. Well, so if I'm trying to do security, doesn't like Kubernetes do this? If I choose to take my serverless function and deploy it in Knative to a Kubernetes cluster, isn't that just kind of handled? Doesn't containers just solve this? Well, no. Here's kind of an environment diagram of Kubernetes. We see that as we come in, a developer will run kubectl commands against the API server. The API server talks to the etcd database through the controller manager. The scheduler, noticing a concern, will hit the controller manager to go find a kubelet that will actually schedule the work. Users coming in will hit a load balancer, land on kubeproxy, and what you can see is that there's lots of pieces for scheduling work. There's lots of pieces for ensuring the things are running and restarting them if there isn't. But there isn't a whole lot of things for securing the content inside that pod, inside the container. That's what we're going to take on. Kubernetes is great at being a firewall to stop intrusion, but it does little for securing our content running in the container. Once they've gotten in through port 80 or 443, they're in. Well, similarly, doesn't container orchestration kind of do this? In a typical environment, not virtual machines, we would have our hypervisor, maybe this is Zen or VMware, and we would install our containers inside of their sandbox together with the operating system and our apps dependencies. Where in containers, we have that hypervisor and we have our containers. So it is that sandbox mechanism, but each of these are on the same network by default and can communicate with any other container. Similarly with Kubernetes namespaces, they're all on the same network. And so they can do curls against each other all day long. Once you're inside the cluster, you're inside the cluster. So looking at Kubernetes, Kubernetes is a firewall in front of our machines. Its goal is to keep all of the pods running, not to keep the content in the container secure. It can do a little bit at noticing that there's unexpected resource usage and killing that container, but Kubernetes' goal is to keep Kubernetes safe. Our job is to keep our containers safe. So what is a Docker container? Well, a Docker container has a file system, it has users installed in it, it has a process running, it has ports that are open, which is pretty much a Linux machine. If we think of a container and how to secure a container, we can think of it a lot like securing a Linux machine. So, well, it is a Linux machine, except it's not. It's ephemeral, it's short-lived. It's isomorphic, it doesn't change, and it's deterministic. It's the same every time. But for the most part, the same mechanisms that we use for looking at securing regular machines are the same mechanisms that we can look to here. The OWASP top 10 is definitely the way that we enumerate our concerns. And every container can communicate with every other container. So once they pop one container, they're often able to pivot and attack other resources within our cluster. So what are threat vectors? And this is definitely not exhaustive. I love that each of us have kind of enumerated our threat vectors. I love the concept of kicking off threats from installing packages. But for the most part, I'll enumerate these threat vectors. We could have CVEs in installed software. Our app could have vulnerabilities. Maybe we're running with excessive permissions or exposing secrets. Perhaps we have environment variables that give us too much access. And so these are the types of things that our attackers are trying to get at. And so we host content through these containers. We're responding to probably HTTP requests or TCP or UDP requests. And they're making these requests into our system. So we can kind of think of, are we leaking data out? And are we validating the requests as they come in? So the good news, because we have ephemeral isomorphic hardware, if we find a problem in a container, we can throw that container away and start up a new container, provided that they haven't pivoted to other resources that we need to also sanitize. Sanitizing a container is pretty easy. Now that's the problem, is once we sanitize the container, has the infection spread yet? So types of tests, ways that we can validate that our container is secure. We want to do unit and integration tests of our code. We'll want to do static analysis of our source code, look for known vulnerabilities in our dependencies and things like that. There's that machine inventory. We want to be able to know all of the software that's installed on our system, both operating system packages and application libraries. And we may choose to do open source license compliance or other checks to ensure that our container matches our security policy. And then ultimately, we'll take the results of these 4 groups of tests and we'll run them through our policy validation. Maybe our policy validation is any failing tests mean that the container doesn't ship. If you have a failing unit test, we don't go. Or maybe the policy is we accept low vulnerabilities in our containers, but we don't accept medium or high vulnerabilities. You know, ultimately choose that policy that makes sense for your organization. First up, unit tests and integration tests. I'm not going to beat a dead horse. Just do it. Static code analysis. I'm not here to suggest a software package, but as you grab these slides from robrich.org, all of these blue links are URLs that you can use to click into each software package and take a look and see how these work. Ultimately, get with your team, get with your organization, understand your needs for static code analysis, and pick the tool that best matches your platform and the framework that you work with, the language. Once again, just do it. License analysis. And not here to talk about specific vendors, but as you start searching for this, you could Google white source and black duck, and you'll likely find a lot of related packages that do similar things. So, ultimately find the package, the license validation system that works for you. And the cool part is both white source and black duck have ways that kind of wander into what we're going to talk about next as well. Policy validation. This is that spot where we review the results of those 4 groups of tests and decide, is this a go or no go? If there are any vulnerabilities that are beyond our tolerance, we'll choose no go. If the urgency within our organization to patch this to get the next feature out is high, we may choose to go, even if some of the tests have failed. Ultimately, get with your team and understand your level of pain here. So thus far, what we've looked at is pretty much standard stuff. They can all kind of fall into, yeah, I know, sorry. We've done this for ages with co-located machines, with virtual machines. Now, as we look to containers and serverless, where's the serverless bit in this part so far? And that's where we get to container scanning. Container scanning is a great way of taking a look at all of the layers in our container, understanding the content that is there, both operating system packages and application libraries and application code, either compiled or otherwise, and taking a look at that isomorphic machine and understanding what it is. Now, the cool thing, because it's isomorphic hardware, the moment that we've scanned a particular container layer is the moment that we understand all of the content within that. We may need to refresh our vulnerabilities list against those software versions, but the software versions won't change. We don't run npm install or Windows update inside of a container. Once we know that container is as we expect, we can, for the most part, presume that it's a read-only system for now. That is an assumption. And so if the container gets popped and other software gets installed on it, of course, now that isn't a known assumption, and we should evict that container. But as we're looking to see if we have this go or no go scenario inside of our container platform when we're getting ready to host it, we already know what's in that image before we launch it. And so we can say, yep, all of that software is still secure enough for us. So when to scan? There's a couple of places where we can hook into scanning, and this is really, really interesting. We think of a DevOps pipeline traditionally as the content on the build server, and that's definitely a place where we can do container scanning, and I would recommend doing it there too, but there's other places that we can look at as well. One of the assumptions of doing container scanning only in the DevOps pipeline is that we presume that that's the only way containers can get into production. If that's not the case, then we may need to look for other hooks as well. We can scan the container registry, presuming that all of our containers come from our trusted container registry. We can notice new containers appeared in the registry, and we can schedule those for scanning as well. Kubernetes webhooks are also a really, really interesting thing. Let's set that aside for now because that is a really, really cool way of hooking in here. And we can scan the production cluster. Periodically, look through the production cluster and validate that all of the containers are known containers, that all of them have passed their audits. If a new vulnerability is discovered, we can now identify containers in production that no longer meet our policy and either choose to immediately terminate them or choose to schedule new builds that will replace those containers with less vulnerable containers. Kubernetes webhooks. Let's pop that open because this is really cool. This is straight from the Kubernetes docs. Here's that blog post that identifies this mechanism. In Kubernetes, we have this mechanism of starting with this pipeline that schedules each pod. And there's a couple of places where it can reach out to web API endpoints to do things. Here's this mutating webhook that will go call all of these scheduled, all of the APIs that are registered here to say, do you want to change anything in this request? Similarly, we have a validating admission webhook. Here we could go reach out into our container scanning platform and say, are the containers identified in this pod approved? If not, we can completely block launching them straight away within Kubernetes' launch infrastructure. So at that point, we can be pretty confident that there aren't any containers running in Kubernetes that haven't been approved by our container scanning approval process. So choosing a container scanner. I'm not here to pitch a particular product. I would invite you to click through to each of these blue links as you grab these slides from robrich.org and pick the one that best matches your tolerance for open sourceness, for cost, that has the features that you're associated with. I really don't want to pick one, but for the sake of demos, we do need to pick one so that we can demo something. And so I'm going to pick Anchor. Anchor? Anchor? I'm not sure how to pronounce it with this dangling E there, but that's the one that we'll look at demoing. It's not a particularly great one, but it is very free and open source, and that makes it decently popular. So again, choose the product that you're looking for. So Anchor. What's interesting about Anchor is it will take the containers that you give it, and it will scan the contents of the container, looking for installed packages, either operating system packages or libraries used by your application, match those against its database of known vulnerabilities, and be able to tell you if your container has any concerns. So Anchor, free and open source. It runs as microservice containers. It does the software inventory piece, which is really helpful. It scans all of the software for CVEs. On the downside, it is not fast. And the docs are not great. I often found places where docs would link to each other, or docs would link to other docs that then in turn would link back to the first docs, each of them assuming the other would add additional clarification. So yeah, your mileage may vary. To start up, here's another blue link, Anchor docs, that will get you started directly with how to get fired up with Anchor. You start by downloading this YAML file. And let's flip over to VS Code where we have that YAML file loaded. Here's that YAML file. And the cool part is it downloads this Anchor engine container, and it starts that Anchor engine a couple of times as the different microservices associated with this application. On the one hand, why do we have all of the microservices in one container? Is this microservices or is this a distributed monolith? Ultimately, the only external dependency it has is this Postgres database, which I'm sure you could put elsewhere. Postgres is that mechanism that it uses to store the vulnerability database. Next up, Docker Compose up, and that launches all of the things. And then you can do this, Docker Compose exec API to exec into the API container to run bash, or you can pip install the Anchor CLI on your machine. The cool part, once you have the access to the Anchor CLI, now you can run various commands. So for example, they invite you as you start up to run Anchor CLI system status. That will tell you, yeah, all of the microservices are working, they're communicating with each other, they have access to the database. And then Anchor CLI system feeds list. And in their docs, they very specifically call out, it may take 10 minutes to populate all the scan data. 10 minutes. Here's what it took me. I started on 6:20 and it finished on 6:23. It took me 4 days to get all this content into place. And this was it just running. I don't know if that's a tribute to the strength or lack thereof of my local environment, or if it's just the process of doing it. Later in their docs, they do specify that, yeah, this may take many hours if you choose to resync it. For me, it was many days. But understand, as you get started with Anchor, you do need to go download all of those definitions. And for me, I was scanning an Alpine container and using a particular package feed. And so technically I only needed those two, but yeah, I'm going to get feeds for CentOS, Debian, RHEL, Ubuntu, and these are each of the vulnerabilities that they've identified in these particular packages so that it can say, oh, I found this package. I know that this is okay or that this is vulnerable. So we've got Anchor installed. We're waiting for the system feeds list to run. And ultimately, once we've gotten that feed list, then there's this pretty standard step of getting your container scanned. Anchor CLI image add will add the image to be scanned. That's an asynchronous scheduling operation. So it's not actually doing it yet, but rather queuing it, and it'll return right away. If we want to, we can then wait for the image to get scanned and then ultimately get a summary of that image scan. Once we have that summary, we can take a look at that and say, yeah, I'm done. I'm good. Or we can say Anchor CLI image vulnerability, vuln, and take a look at the particular things. This last argument is what type of thing do we want? In this case, all will return everything, but we could specifically say, I would like the OS, or like NPM packages or gems. It can harvest the results specific to each thing. I really enjoy too that you can list all the install packages, grab this and set it aside together with the hash of your container. And then later you can say, hey, I know all of the software that's in all of my containers. Are any of them vulnerable now? And so that inventory can be really, really helpful. Based on the results of these commands, you may choose to fail the build, or you may choose to wait for another step of a policy validation where you can say, here's our company's policy, and here's the results of our scan. Is this container good enough? So let's do exactly that. Let's fire up a build. Here's our build that does some pretty basic things. It's just going to Docker build. I'm going to tag it with my app straight away. I would then Docker push it up to my repository and do a kubectl apply to get that content into place. Now I want to add Anchor. Now I'm going to add it right here between build and push so that I can validate my image before I potentially infect my repository. Once I've pushed, if my container isn't good enough, hopefully I'll catch it in a later thing. But really I want to fail the build straight away. So let's add Anchor to this. Anchor image add, there's my image that I just created. Here's an additional flag that is really cool where I can pass in the Docker file. And now it can double check and validate that it's got all of the packages that we've installed or copied in. I'm going to wait for that image to run. This takes 3 or 5 minutes. It's going to start by downloading the image if it doesn't have it already. In this case, it's in our Docker registry locally, but it's going to download that image. It's going to do that scan. And so waiting for this is really a really elegant way to have the build wait. If you don't have the tolerance to do this, perhaps scheduling it and coming back in later and then removing packages from the registry or killing pods might be a mechanism if you don't have that tolerance to wait the 3 or 5 minutes for this step. Ultimately, then I'm going to go grab all the vulnerabilities. I'm going to export this as JSON so that I can grab this vulnerability.json file and then go look through it. I'm going to do some magic in JQ to go check for any vulnerabilities. And if there are any vulnerabilities, I'm going to fail the build right here. -E says, hey, if you don't match, then return a non-zero status code. Set -E right here will notice that I failed and fail the build. That's pretty cool. I'm also going to go grab that image content, put it into content.json, and then store those two things as build assets so you can harvest them later and analyze them in other ways. Once all of this passes, once I know my container is good enough, then I'm going to Docker push that to my registry. Now, if the build failed up here, I'm never going to get to this step. I'm never going to get my poison container into my registry. I'll never get this poison container into my Kubernetes cluster. Ultimately, then, once I've pushed it, I can kick off that kubectl apply. And now I know that my container is scanned, my content is good for now, and I can run this safely in my organization. So that's getting content in my cluster. Now, ultimately, I would love to show you some Anchor CLI processes of kicking this off locally, but it takes 3 minutes. So I'm going to forbear that and just identify that here's that build that will get you to the mechanism of incorporating this tool. As you choose a tool, find the steps that will kick that off for you. So that gets it installed in a local environment. If I want to do some more remote things, GitHub Actions is a really elegant mechanism to install Anchor. And the cool part is that this mechanism is a whole lot simpler. I just have this one Anchor scan task, and it will go do all the things. So I've created a container scanning mechanism. Here's one repository called container scan pass. Here's another repository called container scanning fail. And you can get at them here from these two links here when you grab the slides from rawrich.org. And we can go look through each of the things. Here in container scanning pass, I have the code that I assume is good enough. It was good enough at the point where I published the sample. And how do I kick off that GitHub action? Well, I'm going to come in here to actions, and when you don't have any actions, then this is completely empty. And I'm going to click new workflow. What I love about this is it will kind of walk us through, well, what do you think your workflow looks like? And I can pick one that says, oh, I think it's a node workflow, or it's a Docker workflow, and it'll get you started with this file. Because I have a file already in there, let's go edit it and take a look at it instead. This file just happens to end up in .github/workflows. There's nothing magic about that folder. It's just named that. And then here inside the workflows, here are the different workflows that I have. And I just happen to have one. I named it docker.yaml. I created it using exactly that same mechanism. And here in that docker.yaml, on branches, so every branch, let's do that process. And this is not that unlike the build.sh that we found. Step 1 is checkout. Step 2, Docker build. I'm going to do a Docker build dot -- file is Docker file. It's probably a little bit gratuitous, but it's kind of nice to document it. -- tag. Let's tag this as container scanning and the GitHub SHA. So I know that that's the SHA that my container is to run with. Here's that Anchor scan where I just reference that scan the container name. I reference the Docker file. I say, yes, I would like to scan for app packages. They note that this may make it take a little bit longer, but I would rather know for sure that all of my content is good. Fail build on true. I've not gotten this to work. You know, even if I have vulnerabilities that don't pass my policy, it seems to still succeed. So I'm going to do this. Let's show all the Anchor results, all the JSON files. We'll just dump those to the console log. I'm going to upload those as build artifacts as well. And then I'm going to use JQ in a similar way that I did in the build.sh to go look for any vulnerabilities anywhere. And if there are any, I would like you to fail the build. So we have this build here in our, you can see how many times it took me to go futz with it. Yeah, when you reference a Docker file that doesn't exist, bad things happen. Or how many times did fail on build not fail on build? But here's that container scanning fail repository and the container scanning pass repository where we can take a look at those results. Let's look at this build run. So the Docker build, it just does the normal things, pulling the thing, building the container, everything worked great. Next up, Anchor scan. The Anchor scan doesn't have a whole lot of output. It just says, hey, I did all the things. I love that I didn't need to synchronize this database, by the way. GitHub kept their Anchor scan database up to date. Show the Anchor results. Here's where we're looping through each file, catting the results. So we can see it went looking through things. It didn't find any NPM packages, didn't find any Java packages, gem packages, but it did find a lot of content here in my OS. So each one, it's identifying the license associated with this package. I can use that as I'm taking a look at, does my container contain any software that I'm not comfortable with? So it will loop through all of the things and take a look at all of the content. I love this content where it just kind of summarizes all of them. That's a great JSON file to ingest and take an inventory of all the things. This content includes operating system things and all of the results from all of the package managers. Policy evaluation. It's going to go look through the default policy in this case, because I didn't specify one, and it's going to look at each of the rules and say, hey, did that rule pass? In this case, scanning all the way down at the bottom of the policy section, it's going to say status pass. This was good. Towards my list of vulnerabilities, here's all the vulnerabilities it found. It found none of them. So that's pretty cool. As we look at this build run, we can then download the Anchor reports. We chose to upload these. And so, clicking these to download them, that would be really elegant. Similarly, in the container scanning fail, ultimately this build failed. Looking at that build result, it did all of the scanning. We show the scan results here. We upload those into the repository as build assets. And then here's that JQ check to say, hey, are there any vulnerabilities? We did find vulnerabilities. We failed straight away. So let's pop open that list. Here's all of the content that we downloaded from Anchor reports in a failed build. So we looked at the OS content previously. We didn't find anything in any other ones. But in this case, I did install some NPM packages. Here's those NPM packages and their versions. And looking at vulnerabilities.json, here are those vulnerabilities that it found in the packages that I chose to install in this failing container. So with each one, we have the feed that it came from. We have the package name. So here's Yargs. This Yargs version was vulnerable, or rather Yargs parser. Here's the package version. Here's the vulnerability that it is vulnerable from. And in this case, we have the severity here as medium. Now we could use that medium severity to create a policy in our organization to say, medium and higher will fail the build and low will not fail the build. Or perhaps we have medium or higher, but with a patch is enough to fail the build. But if there's a medium or higher without a patch, then we won't fail the build because, well, there's nothing we can do about it. But here's that list of vulnerabilities. And so we can import both the vulnerabilities and the content into another system that we then can use to audit our containers later. If later we learn of new vulnerabilities, we can look through the content file, our content database, and understand which containers are now vulnerable that we need to reschedule and rebuild. So this GitHub action was actually a lot easier to integrate than the build, but you can do either. They also have a plugin for Jenkins and webhooks for Kubernetes that allows you to jump in straight away there. Kubernetes only protects itself. We secure the containers. Ultimately, my pitch, use container scanning. What are your questions?
Thanks, Rob. Let's see if we have any questions. I have one. Did you get a chance to see that working on AWS as well? I know you're more familiarized with Azure.
Have I gotten it to work on AWS? The cool part is
AWS
once you have
containers.
those containers running, you can run them anywhere on any Kubernetes cluster. So yeah, in AWS, it would work just as well.
Yeah, so the reason I'm asking that is that I wanted to know from your experience, if you see any added value for that, again, for example, their built-in solutions like AWS Inspect and things like that. Yeah, they also have container scanning.
Right.
Do they have it
I
on
tried to
Azure as
stay
well?
cloud agnostic here, but
Yeah.
yeah, Azure has their own container scanning. AWS has their own container scanning. And if that best matches your organization's needs, you're not hybrid cloud or cross cloud, then maybe integrating with AWS's cloud scanner is the perfect solution for you. Maybe that's a little bit more tighter to your process. And so you don't need to, go look for an external tool and spin up additional clusters or additional containers in your cluster. I think if you're AWS only, yeah, use AWS's container scanner.
No, but doesn't necessarily AWS. I mean the built-in scanners. That's
Right.
what I'm trying to get at. Is it different than the built-in scanners that they have in their own platforms?
Similar arguments could be made about virus scanners for computers. There are features that are better and worse in many of them, but for the level that we're looking at, typically the features are somewhat irrelevant and just having one is more important. For the purpose of this audience, get one, get any one, and you'll be definitely a leg up. As you get deeper into it and learn more about how they work, you may develop preferences that will highlight a particular package, and that's definitely the package for you. At this step, AWS's isn't any better or worse than Azure's, isn't any better or worse than Anchor.
Okay, we have one question from Fernando.
I love that. Any thoughts on recommended practices of how to do this without causing a revolt by your engineering team? Yes, I love that part. I finished my work, me developer. I'm here to throw it over the wall to you, security ops person. Can you just plug it in and make it work? And of course, we as ops people go, no. The hard part is it's easy to put this in when it's greenfield and you're just first building your DevOps pipeline. It's a lot harder to add this to an existing DevOps pipeline because you may have legacy containers that are vulnerable and you really don't want to go back and fix it. What I like to do as I start integrating this into a pipeline is do a phased approach. First step, let's get container scanning in place in a really non-invasive way and not fail the builds, just start collecting information. It might be news to the developers that the software that they've written has vulnerable packages in it. Maybe that's enough to get them started, maybe not. In time, a month or two, then let's start turning up the thing. Anything with severe vulnerabilities in the build pipeline should get evicted. In time, can we turn that up to anything? I like Anchor's default policy where it says medium or higher with remediation steps. If it's possible for us to fix it and we haven't yet, let's fail the build. I'd also like to put in content around putting scanning in the container registry because that doesn't impact production performance at all. And so if we can get container scanning in those two places, in the build and in the registry, where it initially flags, but eventually fails, then I think that's a way to kind of ease this into an engineering staff. Now, ultimately, it does take a while to do these scannings. And if the goal is, hey, I want to build and deploy really fast, like within seconds, not within minutes, it'll be a really difficult sell. Yeah. Pushing back, how vulnerable do you want your system to be?
Yeah, no, I agree with you. I think there's one thing is missing and is very maybe emphasized better in the serverless world is that you still have to take care of your code rather than just scan the container for known vulnerabilities and CVEs. You happen to have to build code, like actual code that I'm not talking about importing libraries or OS, but writing your own Python or Node or whatever that is vulnerable, and you have to take care of that as well.
And you can't outsource that. However serverless you go, if the only thing that you're responsible for is that one Lambda function, you can write an insecure function.
Yeah. I've been dedicating my past 2 years for doing that, for going into conferences and show people that no matter how they think their solution is protected by the environment, by the provider, but whatever, if they write vulnerable code, then it's still vulnerable. It doesn't matter whether you shift or you give to the providers.
And sometimes it's just a matter of pointing that out to engineers to do a search through our code, looking for vulnerabilities and point out how they can be exploited. Not pointing out that they are being exploited in the wild, but rather, because you've coded it this way, here are the things that I can do to attack our system. And just showing them that that's possible sometimes is enough to help them understand the severity of their choices and to choose differently.
Yeah. Okay. No more questions. So thanks, Rob.
Yeah. And if you find questions later, if you think of a great thing tomorrow or next week, reach out to me on Twitter at Rob_Rich. You can grab these slides at robrich.org. And you can also click on contact me from robrich.org and send me an email.
Also, the conference was recorded or is still recorded. And once the recording is available, I'll publish it on the website into your emails, the ones that you registered with, and on social media. So you'll be able to grab whatever you missed or you want to remember. And I promise personally to try to find new content and updates. Maybe this is what I'm trying to do, is to create some kind of a serverless security community that outside of serverless is very good for developers. And I completely agree with it. I mean, it can help you build things really fast and really quickly, and don't spend your time on things that are not important. But I think that the security aspect of serverless is not yet known, where it differentiate from the monolith world or even microservices. And there are some different aspects to that, and I'm trying to find new content around that. And so thank you everyone for joining. I'll update you whenever the recording is available and whenever we have new content. Thanks again, and feel free to reach out on LinkedIn or wherever, Twitter or email, and see you around. All right, thanks everyone. Stay safe.